This is a problem. We're going to use the exponential growth and decay model to solve this problem. The half-life of a certain substance is 50 years. How long will it take for a sample of this substance to decay to 40% of its original amount? So we've got A equals A sub 0 times e to the kt. If we want 40% of its original amount, remember, of is times, and the original amount is A sub 0. So that means the amount that I want, that's A, is going to be 40% times A sub 0. So I'm going to put in 0.40 A sub 0 for A. And that's going to allow me then to get rid of the A sub 0 if I divide both sides by A sub 0. And so I get 0.4, I don't need the 0 afterwards anymore, equals e to the kt. Now, the problem is, how long will it take? I'm trying to solve for t, but I still have another variable in the problem. I have this variable k that I'm going to need to deal with. What we're going to have to do to figure out that value k is use this information about the half-life. The half-life is the amount of time it takes for the substance to decay to 50% of the original amount. So I'm going to write this model down again, but now I want 50% of the original amount. I want the half-life to pass. And I don't know what k is, but now I know what t is because the half-life is 50 years. So this little trick works on this part too. I divide both sides by A sub 0 so that that goes away. I get 0.5 equals e to the 50k, and now I only have one variable. So I can take the natural log of both sides, I can bring the exponent down in front, and if you've done a few of these problems, we know this just says then e to what power is e, so that whole thing is just equal to 1. So I would get 0.5, natural log 0.5 divided by 50. On most calculators, you would hit natural log, parentheses, 0.5, close parentheses, divided by 50, enter. On some calculators, we would have to put in the 0.5 first. 0.5 ln divided by 50 equals. And no matter which value you do here, if I round k and do lots of decimal places here, I'm going to get maybe negative 0.0138629 if I round. No matter what the problem says at the beginning, and I didn't put an amount to round to here, it usually will say how much to round to. Whatever it says to round to for a final answer, if you're going to use a rounded value of k here, you need to carry several more decimals. So if I want to round to 1 or 2 decimal places for my original problem, you probably want to carry out 6, 7, 8 decimal places for k. And I'm going to use this now, this value of k, I'm going to take and plug that in up here into my problem that I had started earlier. So I've got 0.4 equals e. Now I put in negative 0.0138629t. And I solve like I did the other one. Now I take the natural log of both sides. That means I can bring the exponent down in front. And then to find t, I would just divide. So, again, on most calculators, I would hit natural log. It would start a set of parentheses. You'd put in 0.4, close the parentheses, divide by this negative number. Be sure you use the negative button and not the subtraction button. If yours is a calculator that acts a little backwards, we just have to put in the 0.4 first. And we make the number plus or minus after the fact, like that. And so, whichever way you get for this, if I look at this, I get 66.0966. Maybe the directions say round to the nearest tenth of a year. So in that case, I'd look at the 0 and one more place to the left. So that would say t is approximately 66.1, and my unit of time up here was years. Now, one thing that makes a little bit of sense here, it said the half-life was 50 years. So if this substance sits around for 50 years, we'd have exactly 50% left. If we're sitting around 66.1 years, then that's more than a half-life, so more than a half would decay. What we found is there's only 40% of the original amount. That means 60% has decayed. So that is more than half, and that makes sense with this underlying setup of the problem.